All right, everybody, good morning. This is our last alumni panel for this quarter, which is really exciting. We have the area of impact of air and space, and we have two fantastic panelists, Angela and Hannah, who've been fantastic stewards to the department ever since they graduated. So we're really excited to also get them here to serve on today's panel. I'm going to be moderating for you today. And so just a reminder, we have the Slido for questions to the panelists. Please submit any questions that you have there, and then I will infuse those throughout today's conversation. So we're going to get started, and we're going to get started by having both of our panelists give a brief introduction to themselves, and then we'll jump into some questions. So Hannah, do you want to kick us off with a brief introduction of whatever you feel like including in that introduction, and we'll move from there.
I'm Hannah Locken. I graduated chemical engineering with a bachelor's in 2019. I'm currently working at Boeing in Huntington Beach, California, where I'm an electrical materials and processes engineer with a focus on printed wiring board fabrication.
Awesome. Thanks, Hannah. All right, Angela, give us a brief intro as well.
Sure. Yep. So my name is Angela Kimber, and I graduated from ChemE with BS in 2017, and then went on for a graduate degree master's at University of Michigan in aerospace engineering. I'm currently a senior mechanical design engineer of fuel systems and combustion products, mostly fuel nozzles and ignition systems at Woodward Incorporated. And I work in Zeeland, so about 40 miles southwest of Grand Rapids in West Michigan.
Awesome. All right, this is going to be exciting because this also brings up Angela with your master's degree, and then Hannah working for Boeing, like a huge local company. I think this is going to bring up a lot of questions from our audience about how you even get involved in this space. But we'll first just start off with maybe you can share with us what your day-to-day is like, so we can get a better sense of kind of what your role as a chemical engineer working in the air and space sector is like. So Angela, do you want to give us a first glimpse into what your day-to-day is like? And if it's evolved since you started, that would be great to share as well.
Awesome. Yeah, it actually has evolved a little bit since I started. Most of that's because as I've built my tool set, I've been able to kind of grow autonomously and do unique R&D work depending on what contracts are coming in. So we do a lot of partnership with NASA. We're doing a big project right now with Argonne National Labs in their advanced photon source, where we're looking at atomization of sprays, and we build these nozzles that atomize fuel in commercial and military aviation engines. And so this is fundamental work. So I'm doing a lot more fundamental work as I kind of wade more from toe deep to like waist deep into some of these waters as I build my skill set. But when I started, I had left, my graduate degree was mostly focused on electric propulsion systems in aerospace, so very different from commercial aviation. But I was doing electro sprays, and so there were some commonalities there. And when I started, they pretty much put me in a design role where I had to relearn a lot of things. And my chemical engineering skill set serves me more now than it ever has, whether we're working with, having to calculate fuel properties or hydraulic circuits when I'm creating a fuel nozzle. All of those mass transport, that work that we did, in our transport courses really has served me well. So my day-to-day can be anything. It's very random depending on kind of what's going on the production floor. So there's an aspect of my job that supports the production of manufacturing of these fuel nozzles. So there's weld and very unique brazing applications, lots of metallurgy. So some of that come in handy, and a lot of material science engineers that I work with on a day-to-day. But I would say the most consistent thing about my job is that I'm always working with a large team of people, whether it's our customers, whether it's another government or DOE lab, whether it's with another site within Woodward. We have material science engineers that work across the site. We have other engineers for different fuel system components. I do a lot of work with high temperature sealing and elastomers and polymers. And so we're working with supply chain folks and testing labs. And I would say that's the most consistent thing about my day-to-day is I'm working in very large teams with lots of different people who do all kinds of different jobs. And I rely upon them as an expert to do that. And then I bring my expertise, which is, usually a little bit more niche, in that I have chemical engineering background, I have materials engineering background, I have aerospace, and all of that comes to combine to solve whatever problem we're working on, whether it's a production issue on the floor to try to get parts out safely and quickly, or if it's maybe an R&D question that we're trying to answer in our combustion lab and we don't understand what's going on there. So it is quite varied, and I think that's why I like it so much.
Yeah, that's awesome. And I think it also highlights the diversity of types of positions that you work with as well. I know that's a question that comes up often for our panelists, is who do you work with on a day-to-day basis? And it sounds like in your work, you also get to interact with a lot of different types of engineers, different types of technical roles, but then also, kind of extending outside of the company more than just sort of the engineering space. That's neat too. And we'll circle back to that and later on in our discussion as well. Hannah, Boeing is also a huge company, and there's so many different aspects of what you could do at Boeing. What is your day-to-day like, and can you dive a little bit more deeply into the specific part of the company that you work in?
Yeah, so my day-to-day also varies a lot. My team specifically kind of works to contract out to any program that needs us. So one week I'm working, SLS rocket, the next commercial airplanes, defense, satellites. I do the whole span, but my specific role is as the printed wiring board fabrication expert. So I'm the lone designated expert for the company. So anyone that needs help with printed wiring boards gets directed to me. So whether that be, the design, they've had difficulty producing it, and I'm supposed to, interface with our suppliers and figure out what the problem is. Do drawings need to be changed? Is it an issue with the supplier and we need to go somewhere else? If we go somewhere else, I'm responsible for those qualifications of the new supplier. We also do quality inspection of the printed wiring boards before Boeing actually buys them. So I lead that lab where we've got 5 people right now that do the inspection. So there's a lot of helping them when there is problems that come up about, this whole lot of boards we can't buy. Then there's a lot of meetings between the program and the supplier explaining why the boards failed, what's wrong, how can we fix it in the future and move forward. But yeah, all within printed wiring boards. And yeah, like you said, very, very wide range of things you can do at Boeing. I started as an intern where I did wastewater treatment and treatment of airplane wings, right, which was true chemical process engineering. Pretty far from that now.
Yeah. That's really cool. It sounds like it's also involved actually in terms of the topical areas you're working in as well, right? In terms of if you started out kind of more on, I think you mentioned defense, and Angela, you mentioned some defense type of projects too. Mm-hmm. But if you're thinking more kind of water related applications, can you just elaborate on that a little bit? Because I think that was a really interesting aspect to kind of hear that the projects could kind of span that array of applications.
So when I started as an intern, so different job now. I was just
okay. Yeah. So that kind of gets into the evolution of how both of y'all's jobs is. I think, Angela, from what you mentioned when you started, and Hannah, when you started as an intern, but Angela, immediately after your master's degree. That's really neat to kind of hear about too, because it's a pretty quick evolution. I mean, you've both been in your positions for a couple of years, right? Is there something that, I'm kind of going off script here, was there something that really, were you the driver of that evolution, or was this kind of a natural part of your job and how kind of what you were working on sort of just evolved with how the industry or the technology that you were involved with was taking place?
So I was a large driving force in that. When I started out in this position, it was the lab for reviewing the quality of the boards was just me and one other guy that was about to retire. And that was a good chunk of what I did. And that was a lot of what there was with printed wiring boards. There was an expert, but he was on the slow side too. We weren't qualifying anyone new. Work was pretty slow. But then kind of the connection that I had with trying to find more work and things to do and working in the lab, I saw some errors that really expanded the role. So previously we were allowing third-party experts to review quality. And when I found some of their mistakes, a lot of programs decided, yeah, we're not going to allow that anymore. So then it all started coming to me. So that's how I ended up the lead of a lab was that then I had to train all of it's going to be about 10 people by the end of this year to compensate for that volume. And then, yeah, just continuing to then see being involved in the programs and trying to help them beyond just my normal assignments. Yeah. And then also seeing everything that's passing through the lab has allowed me to kind of connect those and grow the role overall.
Yeah, nice. I like that. I like that kind of also aligning what your interests were with where opportunity was, and sort of staying aware of where opportunity was and kind of pushing into areas that would give you that growth opportunity, you know, because it was not necessarily something that was directly immediately in front of you, but there was a good kind of sidestep or a redirection that you could leverage. Angela, what about you with the evolution of your work? Was that largely something you took initiative on?
This is everything I've ever been doing since I started to go back to school. And we can talk a little bit, I don't want to get too much into that, but I think it's interesting to talk about how your path is never really straight. And you really, sometimes there are outside factors that influence what you end up doing. Sometimes you're given a project or you're told, hey, you're going to work on this. But I've found, at least within Woodward, and then of course with my academic career, that if you're passionate about something and you find something and you're interested in it and you follow that thread and you pull on it, you can drive where your direction goes. And so I definitely used that, you know, determining what I was going to do after I got my degree at University of Washington, and determined where it was going to take me into graduate school. But even in my career now, like I had mentioned, I had started off, you know, they gave me a little bit of R&D because it was my passion, but I was doing a lot of legacy production support. So things that have been flying for a long time that need just generic kind of support, updating prints, checking quality, signing off non-conforming parts, those kinds of things, into, you know, as I start to get my hands around these projects and I'm diving deeper and I'm finding things and opportunities, that's something that I think is just important for my personal growth, to stay passionate about what I'm doing. And the company I work for allows me to do that. I have a really fantastic group of supervisors and technical fellows who say, yeah, run with this if you can, if it's not going to cost money and you have the bandwidth to do it. And so that's how I got into doing a lot of the sustainable aviation fuels work that we're doing. Is this is something that is broadly covering the entire industry globally, and it's going to affect our products directly. So it was something I saw, oh, we're behind the 8 ball on this. We don't have a team doing this work. It's very well aligned with the elastomer work I'm doing. I'm going to start pushing for this. How can we get support for this? How can I attend these conferences to get this technical background? How can I attend policy sessions in DC to understand how it's going to affect? And all of them are going, why do you go to these things? But 2 years down the road, we now have a chartered project for it, and we're partnering with, you know, large institutions. We're partnering with the OEM engine manufacturers, and I'm the lead on that team. And that's something that, you know, I really had to push for that. It ended up that I saw the opportunity for it and there was a need. And those are the two things. You really have to, you know, if you have the passion and drive for it, you're going to put in, it doesn't mean you have to stretch yourself far beyond the hours that you have. You have to make sure you have bandwidth to do it and you're still getting your other, you know, your day jobs and your other tasks done. But if you see that there's a need for it and you see that opportunity there, you really, I think, have to push for it. And then also I would say that my skill set really allowed really well for that. I'm the only chemical engineer in my plant here because we do so much mechanical and welding and other things for aerospace, although that's not the case as I start to scope the industry in general. There's actually quite a few chemical engineers in the air and space industry as you start to explore outside of the silos of, you know, your school, you know, departments. And it's really been useful to do things and say, well, I have this specialized skill set and this is where I want to drive it. And this project's unique to this. And I've been able to kind of carve my way through my path that way.
Yeah, I love that. I love that reflection as well, that it's not a linear path. I think you can both speak to that, but also that sometimes you might be the only, you know, in terms of a type of training identity in the room, and that enables opportunity rather than maybe, you know, sort of closing down paths. So I think that's a really neat kind of perspective to share. I want to kind of step back from that, sort of taking that aspect of being a ChemE in this space and go sort of to where your interest in this area really came from. How did you decide that air and space was what you wanted to pursue with a chemical engineering degree? And then after we get y'all's insights on that, we'll roll it back even farther to starting the ChemE degree. But Hannah, how did you decide about air and space as a field you wanted to pursue? And like, how did you get first introduced to it? That was an audience question that came in, was how your first introduction to the field also came to be.
Gotcha. So for me, it was kind of different because I didn't have like a passion for any of the topics within chemical engineering. I picked it because it allowed for opportunity around through a wide range, and so did aerospace. So it was a field that rewarded the chasing opportunity rather than chasing passion. I mean, it'll reward chasing passion too, but there's a lot of industries that are very focused on, do you love this thing? And at least at Boeing, the fact that I'm able to just 100% go where I'm needed and it's not driven based on my specific wants has rewarded me really well. And even in my interviews, they loved hearing that. And I heard that from other people that came to visit UW and talked about Boeing. Was the thing that I heard over and over again was that they worked for Boeing because they cared about who they worked with, not about what they did. And that really resonated with me. And I liked Boeing. Then, they were the first company that I talked to at my first career fair, and I interned with them, and then I got the job with them. So it always seemed to kind of fit in that realm. And then when I interned, they had a lot of opportunities to kind of listen to executives talk, and something else that they always talked about was how important work-life balance was and having families. And that's a big benefit, I think, to Boeing, where it just also allows me the opportunity to, when I do have kids and everything, to stay working, and they value that balance. So it was, again, I have opportunities to do both at this company.
Yeah, and I appreciate you sharing also how much being able to parse that out in the conversations and the internship, kind of the culture of the company and the commitment to the employee really informed your decision, because I think that's something that we hear a lot about, but it's hard sometimes to figure out where that actually comes in your process. What stage of your process is that something that you are assessing and kind of getting some exposure to? So I think that also sounds like a pretty unique exposure in the internship, to actually be able to hear from people that maybe weren't directly related to exactly what your internship was doing. Was that kind of your sense from the Boeing internship?
Yeah, I was able to. So the team that I interned with gave me the freedom they encouraged me to go to talk to all different sites, all different roles, and kind of find which one was interesting. They also had like some meetings where it was executives across Washington, that we went for a day to the Air and Space Museum, and they had them all talking about, kind of how they got where they were at in their career and what they valued most. And something that I thought was cool about it was that they, for the most part, all of the executives talked about how important their families were, which I thought was a very cool culture to have.
So you were hearing it. It wasn't like it was prompted, or like it was actually a natural part. Yeah, that's neat. Thank you for sharing that, because I think that's also a really important distinction we hear a lot from our undergraduates, is like, do I have to love, or have this like intense sort of passion and desire for what I want to do, or can it be a skill alignment, like a good match for opportunity and skill? And it could be both, or it could be one or the other. And I think either can result in a successful kind of career, right? And I know, Angela, this is something that you I remember some of our very first conversations, and what you were very passionate and excited about opportunities for sustainable fuels, and thinking about how that would be utilized in the air and space industry in particular. Where can you share with everyone, like, where did that come from? Where did that initial inspiration come from? And how did you connect the ChemE degree to that?
So I chose the ChemE degree. I was doing really cool undergraduate research at Seattle Central with Professor Naomi. And so it was a surface analysis. I was actually working in the molecular analysis facility right when I transferred in, because I had been training there for some undergraduate work. So that's kind of where the first spark that got me into an undergraduate research lab that wasn't in the ChemE, because outside of that, my interest had always kind of been in space and rockets and things that go boom, and fuels in general, just, combustion, fire, those things since I was a kid. And also like astrophysics. So like, rocket science was something that was a passion of mine just in general. And these opportunities sometimes present themselves to you. So there were also a couple of seniors in the ChemE department that were making solid fuel for Robert Wingley's lab. And that was, no pun intended, really fueled my interest because I was able to do some work with them. I was building rockets in the ESS. There's a rocket building class. I don't know if it's there anymore, but Robert Wingley was running that program. And some of the graduate students needed help with molecular analysis from some of their thruster work they were doing in the advanced propulsion lab. And they needed someone who had access to the machines and could do some analysis for them. So it was kind of like, hey, I have this analysis skill set. Sure, I'll take it in the lab and we'll take a look at it. And it drew my interest in. I believe it was Brad Holt had sent me a copy of a book called Ignition with an exclamation point, and it's actually now been put back in print by John Drury, and it's all about the history of liquid propulsion. And so there were just all of these kind of people who saw my interest and kind of fed it in some way. And then once I got my foot in a lab and I was working on, the first Husky CubeSat propulsion system, and I was seeing where it was going to go, and we were having critical design reviews with NASA, and I was really understanding what it meant to be maybe an engineer that was associated with something in space. That was kind of fueled my passion further to keep looking as to, okay, I don't want to leave ChemE because I love what I'm getting, and the skill set has, that was a gut check right there. Is this going to give me everything I need for what it is I'm doing? Did I make the right choice? Absolutely. And I think part of that was a lot of discussions with great mentors in the department and elsewhere that said, yes, that you're taking a little bit more of a non-traditional path, but we will support you. There was never a time in the department where someone said, you can't work in another lab and be a ChemE student. It was very well embraced and supported. And at times I had to take classes in other departments to support that role. I took a propulsion class in the AA department. I even took an electronic circuits class in the EE department when I was, trying to learn more about building rocket antennas, which was all this stuff I was doing outside of my curriculum. But I was looking for ways that a ChemE would intersect. And the initial kind of push to get into industry for me as an undergraduate, when I was trying to decide if I was going to go on to grad school or was I going to go look for a job in the field, I was trying to get internships in aerospace. And at the time, they were like, we don't really know what to do with you. You have this crazy, weird skill set. You work in an advanced propulsion lab on like electric propulsion, which isn't really what we do. And you're a ChemE, but you're not a mechanical engineer. And so I really struggled to place internship. I think I applied at like 20 plus places, could not get it. And part of that was I was, logistically couldn't leave the state. I had a kid at home. And so it was one of those things where I had to have a nearby internship, and I wasn't successful in getting one, but I continued to work in other undergraduate labs across campus. I actually sought out a liquid propulsion lab in the AA department with Dr. Carl Nolan and got my foot in the door with a graduate student who was leaving to kind of like, once again, wedge my way in there and say, hey, I want to learn more about this. I'm doing electric propulsion. I want to do more liquid propulsion. I want to get this under my belt, and, taking these other classes to round out my skill set, which then kind of drove me to, okay, I've graduated. I didn't really have the internship experience that I needed to get a good job anywhere. You can get it without an internship. But for me, I had so much research experience and I had the research bug. I love R&D, and it was a passion. So it was like, I'm going to go on to pursue this. I'm going to continue on to graduate school. And that's kind of where I continued to go. So I would say, to sum it up, it was a lot of things and a lot of people that were giving me encouragement to keep kind of pulling on that thread and discovering where I could take my ChemE degree and how far I could take it. And it's continued to serve me well into this day.
Yeah, I think that's a great reflection. It also kind of brings in a question that we get not infrequently, which is, and is submitted today. How does majoring in chemical engineering benefit you compared to majoring in aerospace? I'll also add mechanical, because I think mechanical is a common degree that we see people kind of explore it in the air and space area, but particularly in the interest of fuels and combustions and engines. Was there ever a decision we were deciding between ChemE and aerospace? And if so, how did you process or proceed through that decision?
I'll be brutally honest. When I was looking at transferring from Seattle Central, I really was interested in aerospace, and I did not have enough credits, and I was going to have to go another year. But I did have enough because of all the chemistry I was taking to get into ChemE. And I made the jump of, you know what, these two are, it doesn't determine what the end goal is for it. And I actually had such a passion for some of the chemistry undergraduate research I was doing that it made sense to do that. But I did, it was, a tough call. And it ultimately came down to, is it going to cost me another year of school to do this? So I said, no, you know what? We're going to go ChemE. We're going to go all in, and I'm going to make it work. And so that's kind of how that, then you get in and, okay, how can I do more aerospace focused work while I'm a ChemE? And you just make it for you. I will say once I was about a year into my ChemE program, which is when you kind of figure out what a chemical engineer actually does. I don't think anybody knows right when they start unless you've been fortunate enough to have a lot of exposure and ask a lot of questions of those in the field. And I think it's still changing as we go today. The program changes. It's less traditional. It's more expansive and diverse, I think, across the roles. I think at least a year in, that's when I said, okay, nope, this was the right choice. I'm going to keep going. I love the classes. I knew the rigor of the curriculum that I was getting was going to serve me as far as a skill set, no matter where I went. And that was evidenced by taking classes in other departments where I was going, oh, this is the easiest class ever in comparison to, whatever class I was taking at the time for ChemE. And not even just that. I'm not saying that other programs aren't rigorous, but the ChemE program it's another level of thinking. It teaches you to think of things on a systems level. And you have more I think the transfer courses, you have 3 of them. You don't get that kind of curriculum in the other engineering disciplines. It's broken up more in different sectors of how they determine your I think your focus for at least the AA program, because I have a few mentored students that are there. And certainly the mechanical engineering department is so broad. So you're going to get some similar courses in, transfer and thermodynamics and those kinds of things. And primarily where I work, we hire mechanical engineers. We don't typically find aerospace engineers that want to do this type of work because what we do is so mechanically focused. That's what we end up hiring. So I think, just to kind of wrap it all up, I think I chose ChemE because I knew it was going to give me a rigorous skill set. And I knew that halfway through the classes and when I graduated, and I was still determined, even though I wasn't able to get the job I wanted with the degree I had, I chose aerospace engineering thinking it would get me a little closer, and that's where the research was focused. But I'm not even an aerospace engineer now. Now I'm a mechanical engineer. So the point I want to bring to that is that it's very gray out there. Okay, your degree does not determine that that's exactly, not all the time, but in terms of air and space, there are ChemEs, there are mechanical engineers, there are aerospace engineers, there are quality folks, there are people who don't even have a technical background or an engineering degree that work in aerospace. They do all kinds of manner of sales and marketing, and we need all types of different people to support aerospace. And I think if it's a passion of yours, you're going to get there no matter what. The ChemE degree has so much overlapping curriculum for what you actually do every day in terms of combustion, propulsion, and those kinds of things. So if you want to do combustion work, it makes a lot of sense. Now, if you want to do airframes, if you're talking materials, then you can, put it in there. So there's ways you can make it work for you depending on what type of engineer you want to be in the air and space field. Maybe that's a better way of putting it.
Yeah, no, I appreciate that. I think that's also goes to show how much those extracurriculars that you would get involved with, whether it's through research or even non-core curricular type of elective classes, can really help shape and refine where the skills that you're developing, but also maybe the interests or ways you might apply those, and help identify kind of unique niches where you can really serve like a company or an industry or, a problem in R&D well, bringing those skill sets in. I also appreciate the mechanical engineer reference. We start off the class going over the history of chemical engineering, and one of the quotes we use from like 1880 is that ChemEs are really just mechanical engineers with a better knowledge of chemistry. In terms of where the field started. And so figuring out kind of what it is that ChemE is, I think, as you mentioned, is part of that first year in the program. Hannah, why ChemE for you? Why was ChemE what you went into? Because I know you have a different process of kind of ending up with Boeing, and Boeing has a ton of our alumni. We have so many alumni at Boeing from the chemical engineering department at UW. And so why was ChemE your first, or maybe not your first, but why was ChemE the degree that you ended up in and chose to pursue?
So I decided I wanted to be a chemical engineer when I was in high school, and never wavered past that. And it was I took AP chemistry, loved chemistry, and a lot of the things that they described in that class were, you'd use this as a chemical engineer, and it was like, that sounds interesting. I could do that. And that my school had chemical engineers come talk and
Nice.
as well. And I remember them coming to talk and thinking, God, that job sounds horrible, but I know I'm still going to do this. It seems like it fits me. And, then I searched for schools with good chemical engineering programs. UW felt like a good fit. I'm originally from Colorado. It was out of state, but it was like, this one seems like a good fit for me, and it keeps it broad. Unlike a lot of ChemE programs throughout the country, they'll have a specific specialty like petroleum. But yeah, any research that I did kind of reaffirmed it too. Like, if I think that I can do this, why would I switch when it's one of the top paid? And that kind of thing. And then I entered the program, and it just still clicked with me and just kind of reaffirmed that it made sense.
I really like the practical response aspect of that, of like the fact that it is still the highest paid starting salary. ChemE degrees are still the highest paid starting salary for bachelor's degrees coming out, but also kind of the breadth of the program and the opportunities that could afford. I think that practicality is an important part, can be an important part of when you're thinking about a major and how that degree could go. And then kind of to Angela's point earlier, you can then shape it and morph it. And, the degree doesn't have to equate the exact career that you go into, but it gives you this enabling skill set. Hannah, is there one class that you remember being like really relevant to what you do now, like that you kind of go back to or pull from, either like with positive feelings or negative feelings about having to rely on it or use it? But is there one class that you kind of rely on or that comes to mind?
None of the classes or actual coursework really applies to my job, but it's like the general, how do you think like a chemical engineer that does? And I think that early on in the program, they kind of say that odds are this whole degree is just teaching you how to think like a chemical engineer rather than actually translating direct skills. And that's definitely been my experience. Another big thing I think that the program kind of brought into my career is the focus on, you're not going to get through this degree alone, just nestled at your desk, not working with other people. That the push to, form a team and work together. And a lot of the time the team got assigned where you had to work with people that you didn't necessarily get along with. Definitely is beneficial. I'll see it across people that I work with now that you can tell that a lot of them weren't forced to do that in their engineering degrees. And I think that that's been very beneficial to be just used to that going in.
Yeah, and I think that's also a really great point. We try and message that in our, classes and in the lab courses where you've got teams, that you don't always get to pick everybody, that you get to pick your company, maybe in the culture of the company, but there are a lot of different working styles and there are a lot of different skills different people bring to the table. Some maybe take longer to observe or appreciate than others. But in many times, like you're going to be working with a group of people that you don't get to hand pick for everything. And that can create natural points of tension or different approaches to how you might be achieving a common goal. And I think particularly with both of your jobs, you're interacting with such a wide range of backgrounds and individuals to do your day-to-day work, right? That's also potentially amplified in the work that you're doing. So I think that's a great reflection to kind of share how the structure of how teams are done in your undergraduate degree can also help inform or prepare you for collaborative work when you get into your job. Angela, I know you mentioned transport came up, and for everybody who listens to the recording, I put notes after the panel with like the exact course codes just so people can connect them to our degree. Is that like the main class series that you think about, or are there other classes that you kind of really resonate with, either in ChemE or outside of ChemE?
It depends on the problem I'm trying to solve at work. And very lately, it's been mass airflow, Venturi. We've had some interesting lab results, and it was literally like, let's go back to Bernoulli. Like literally, let's go back and I'm like, remember that course. And I will pull textbooks down as well. So I have pulled, from 310, ChemE 310, the basically the balance book out. Perry's chemical handbook is so useful for a lot of the analysis we do with coking and change of from liquid to vapor back to solids in hydrocarbons. So that I would say the VLE that we did with, I think that was in the programming course with Fentner, that work, I had to predict properties of fuels and multi-component fuels, very complex things that you need a simulation to do, but sometimes you have to backhand with a surrogate or understand your formulations for that. And so those courses, if you're doing fuel property work, are invaluable. So that I think those are the two that I've like literally pulled the book down, pulled notes out of. Oh, and unit ops. We had a unit where we did biojet fuel, and we actually made biofuel from ionic switchgrass or something like that. And that was in Carruthers when he was leading that. And that lab itself, I literally pulled the lab out, partly for the reference papers that we needed to use for it, but it really emboldened a lot of the knowledge that I'm doing for work now and understanding how these fuel properties affect things like surface tension and how these fuel properties affect what we do in atomization and combustion. And so uniquely, just for fuels alone, those two have really been I think the big courses that I reflect back on. But to Hannah's point, yeah, there are overarching skill sets that you get, like analyzing systems or taking something from bench and scaling it up. That is unique to ChemE. Making non-dimensionals and scaling, that is so useful. It was useful in graduate school. It gave me an edge on some of the thermodynamics works that we did with stats and some of the thermo work in Adler's class. So I would say it's kind of an amalgamation depending on what problem I'm working on. And the ChemE program with all those classes kind of teaches you how to solve really hard problems, how to think about a problem, what assumptions to make, what are you working with within your constraints, and then how do you apply what you have to solve it. And just learning how to solve problems that when you get them handed to you at the beginning of the week with your team and you literally have no idea how to solve it. And by the end of the week, you've come up with a solution and handed it in. That's what you're doing on a daily basis here, but with large groups of people, sometimes on a global scale, and you're chipping away at these problems. And ChemE teaches you how to frame that question. It teaches you not really how to answer it, but I would say it teaches you how to ask the right questions so that you can solve it.
Yeah, I think that's a great point to bring up as well, because like you get more and more open-ended questions as you progress through the curriculum.
Yeah.
And that's partly to help prepare for what is usually a very open-ended space that you're working in your day-to-day job. I'm going to follow up with one question we had submitted from the audience. You both mentioned aspects of like very difficult or challenging things about the ChemE degree that might turn people away from the degree in terms of thinking about, maybe the topics that you covered in the classes. You either had to go outside or they give you the broad skill set, but they weren't directly related to things you were interested in. Or there might have been other majors that would have like more specifically deep dived into something that you were interested in. So how did you get past hearing about or kind of getting some exposure to things that maybe you initially your initial reaction was like, oh, I don't know if I like that, and then still choose to go down the ChemE path? And I'll leave that open to either one of you if you want to answer it.
It's a good question.
I know it's a great question submitted. So
I'd say personally for me, I'm like a lifelong learner. So I would find something that I would enjoy about it. So some things that initially maybe I didn't have a lot of context with, I would do external reading about. So I would literally try to find another textbook if I was struggling with it and try to find someone else's viewpoint or perspective of it, or how it would be applied into a real world application. So that's ways you can find interest, contextual interest in something and go, okay, well, I can connect this way. The other thing is that I think I had really great advice from, again, my community college Professor Naimi would say, you may learn something and it's in a field way over here, and what you're doing or the work you're doing is way on the other side of the spectrum, and you don't think there's anything that could possibly connect those two. But a really good scientist, a scientist that makes the largest impact, is someone who has this broad range of knowledge, because sometimes maybe it's not the direct application of what you're learning over here, but there's something associated with it, a problem you run into, or a failure in a fail mode or something like that, that turns out to be highly applicable later on down the road in something that doesn't seem like it's related at all. So you think of it as just collecting knowledge and skill sets this way, and that you never know when later on you're going to be able to apply something from a completely different area. And so I think that general curiosity and hunger for knowledge, and being able to put that skill set in your pocket for in case you needed it later, it proves to be pretty invaluable later on.
Yeah, I appreciate. Hannah, did you have any thoughts? Sorry, I didn't want to cut you off. Any thoughts you wanted to add?
I guess with me, I viewed everything very abstractly, of just every class, everything I'm doing is just practice in solving puzzles. Right. And that's all I'll be doing in my job, is solving puzzles. And it's just all getting me practice in that. So even if this one's a little bit different or a little bit more frustrating or not, it's just the solving puzzles.
Yeah, I think it's you both bring up really great points. This is a great question. We hear about the challenges of the degree. We also, are very much working in a time when we're trying to modernize what the chemical engineering degree represents, to kind of get it away from being, I think, Hannah, you mentioned before, sort of the petroleum, food, chemical perspective. And it's so diverse now that you go into. But I remember when I was starting, I didn't like chemistry. I wasn't good at chemistry. And I really enjoyed math and physics, but I've always heard about the adaptability of chemical engineering. I had no idea what chemical engineering was, but I knew it was an adaptable degree based on how people talked about it, and based on the fact that I couldn't find two chemical engineers that were doing the same thing. And that was, mostly coming from my freshman and sophomore year of class exposure. It wasn't like I was hearing about that earlier than that, but I think you both speak to kind of that adaptability aspect that I think is because of that sort of systems level assessment, and kind of thinking about, Hannah, even in the training, the problems in a very abstract way, or and maybe even fundamental way, where it's not specific to the application, it's how you're learning about the problems, and framing the questions and learning how to ask the right questions of the system that you have. I think that really shows kind of that adaptability. And even both of you are doing very different things in a single sector, right? In kind of the broader air and space sector, but bringing those skills in a way that, you can apply and adapt even on a day-to-day basis. I think that's really neat to hear about. I want to ask one more question kind of along those lines before we get into our rapid fire questions at the end. How, you mentioned a lot of different types of people and sort of projects that you engage with. Have you been able to better see how your role as a chemical engineer is unique in the contributions that you contribute to that space? And I'll leave that open, whoever wants to answer that first.
Yeah, I'll go. So I think that working with all of the different, degrees and areas, what I'm seeing that chemical engineering specifically seems to help with is seeing both the big picture and the details and how they influence each other, like the bigger process. Whether, when you're actually in the classes, when you're looking at the process, you're talking about movement of things through pipes, right? That's the big process. But in the actual workplace, with my job, the process might be where the boards actually fall in the bigger process getting up to the plane, and what steps happen along the way, and being able to explain to people how my piece fits into that. I think that was one of the benefits that accelerated my career of where I am. The people that were in it before me were all materials, and they were very focused on this specific task and all of these details, that they weren't able to communicate how it fit into the bigger process. And that's kind of what grew my position, was that I was, and I was able to communicate that to the other degrees, other positions, program managers.
Cool. Yeah, thank you for sharing that. Angela, what about you in terms of your this experience and how it's refined your view of that ChemE skill set that's coming in?
Right. I think because I get that kind of every day, because I am the only ChemE, there are problems that come to me directly, whether they're chemical or not. Some of it is that knowledge of, hey, this chemical is in this process. Can you help us with the process flow with that? And so there's a unique skill set there in that where, yeah, we have other mechanical engineers and manufacturing engineers here that do that work, but that's not their background. So there's some specialized help there, even reading like an SEM chart, right? And understanding, or even understanding just when you're talking about molecules and elements and how they respond and how they work into something. But I think what's different from what I got out of my undergraduate, and I'm going to relate this a little bit because I was solving problems using ChemE methods as an aerospace student, and sometimes my professors would be like, "Hey, that's not how we solve that problem. You know, you're solving this a different way," which is, you know, as long as you're coming up with the same answer. But I think I was always finding myself kind of thinking about things in terms of how I was trained to solve them. And again, it goes back to scaling things, I think. And this goes for, I think there's some other people who are doing this work, but I would say even if you're looking at, I don't know, let's say physics, you know, you have these, you know, classical physics and you have quantum mechanics, and they haven't been able to really connect the two. It's the same thing with what ChemE does. We look at something, like we said, movement through a pipe, but then we look at the molecular movement, right? We talk about thermodynamics of bulk properties, and then we look at what are the statistical mechanics of those things actually doing on a small scale. And we do that in various forms throughout the entire degree. And I think that's that sort of perspective is completely unique. I don't think that same perspective is shared in, you know, the mechanical engineering group necessarily, maybe in some niche applications, or really even within aerospace, some of the degree programs that are there, just on what my background and from my experience of taking these courses are. So I think that is something that is very unique to ChemE. And I do think that you get more of the fundamentals, as far as you get more thermo, you get more transport phenomenon. And so you just you have a larger muscle set when you come out on those fundamentals that you don't really get that in some of the other engineering degrees. So that would be what I think makes it a little bit unique.
Yeah, I appreciate hearing from both of you that that's very consistent, independent of the fact that you're working in kind of different aspects of air and space, that this kind of ability to look at systems, but also look at scale aspects of systems, length and time scale, whether you're talking about the individual components of a system versus like how those all interact in the broader scheme of things, I think really comes through clearly, but also shows again that kind of adaptability and scalability of the skill sets that you get in the degree. So I really enjoyed hearing about that from both of you. One of the things that we like to try and do, just for everybody who's listening in, is get a rapid fire session at the end. And these are quick questions that we'll put to our panelists that have 1 to 2 word responses, but I think really help kind of give you these little soundbite takeaways. So we'll do that with our remaining 2 minutes. I'll call out which one of you to answer first, so we can get that rapid fire feel to it. All right, Hannah, first question to you. What is a habit that contributes to your success?
Big picture thinking.
All right, Angela.
Curiosity.
Excellent. All right. It's always hard when the second person, like if your answer was the first one, to also say that when we've done this in the past, it's okay to have the same answer too. All right, Angela, if you could go back and do undergraduate again, what one thing would you make sure you would do?
Definitely more data or machine learning.
All right, awesome. What about you, Hannah?
Internships.
Excellent. Okay. Would you start those earlier? This is a quick follow-on.
Yeah.
Okay. Excellent. All right. Last question. Hannah, we'll go to you first. What is the coolest thing about your job?
Freedom.
Oh, nice. I like that one. Angela, what about you?
I was going to say the same thing. Autonomy.
Yeah, perfect. All right. Well, thank you both so much. We're wrapping up. Our class ends at 9:20, so we're wrapping up with a few seconds to spare. We'll give a round of applause to Angela and Hannah. You'll at least hear the in-person and hopefully see the emoji responses on Zoom. So if we can give a thank you to Hannah and Angela for joining us today. I have no idea what sound y'all can pick up on.